Hello, my name is Faith Taylor, and my presentation today will be on mineral exploration. So what exactly is mineral exploration? Mineral exploration is the search for mineral deposits and environments that may be favorable for their formation. Mineral exploration is one of the most ancient human activities, and in the last 5,000 years it has been developed into an industry with modern methods and tools. So one thing we may think of when we think of mineral exploration may be strip mining. However, this isn't the case for most exploration. This is the mining itself. The exploration is itself only a process of collecting the information that we will need. So just a small scale project can be mineral exploration. And as our textbook is quoted, we can select the broad geographic setting most likely to host the type of ore deposit being sought, and within this setting, identify the specific geological environment most likely to be mineralized. Continuing on, the tool that remains useful for exploration is our geological map. Usually a topographic map that illustrates distribution of rock types that make up the bedrock and the surfaces directly above it are used. Alongside with our map, satellite navigation through Global Positioning System, or GPS, enables us to identify areas with specific features and rock types to detect where these ores can be mineralized. However, this does not guarantee that there is an ore deposit in this location. This is why other methods such as geophysical and geochemical surveys must be done to narrow its search. Okay. So some of the different methods themselves are geophysical, geochemical, drilling, and remote sensing. Most of the methods that will be discussed do not even require visiting the area to be explored. However, all methods must be concluded with drilling to conduct whether or not the site is viable. And all of these methods will be discussed in further detail. To start off, we will discuss geophysical method. Geophysical method depends upon contrast between the physical properties of ore bodies and those of their host rocks in the four main areas, which are gravity, magnetism, electrical properties, and radioactivity. Many ore bodies contain minerals of high density, which increases the pull of Earth's gravity on land surfaces above them. These changes are not detectable to human senses, but they can be measured with gravimeters. Dense rocks in the subsurface cause gravity reading measures above them to be higher than average, so this reveals their presence in the local gravity field with its irregularly high gravity, so it can be detected from a larger area just based on its gravity. The next geophysical method is magnetism. Ore bodies beneath the surface sometimes contain concentrations of weakly magnetic materials. So just as gravity, these minerals produce positive magnetic irregularities in the local magnetic field. And they can also be detected through other instruments, but these are known as magnometers. Continuing on, we have electrical properties, and these can be detected in metallic minerals, which have different properties from the silicate-rich rocks around them or that they inhabit. And they can be detected through these conductive properties by their weak magnetic fields that they generate. And lastly is radioactivity. Radioactivity can be used to detect minerals that contain uranium, thorium, and potassium. Okay, next is the geochemical method. A geochemical method detects the presence of ore deposits more directly than geophysical methods. This is done by using an aspect of its unusual composition as a chemical fingerprint. Although these deposits are not on the surface of the target area, they may be surrounded by low levels of mineralization dispersed over wide areas. These minerals can be detected through the analysis of the exposed rock and soil in the immediate areas of the target, or they can be determined through the chemical composition of the nearby plant material or nearby streams and lakes. Next, we have drilling. The geophysical and geochemical methods are indirect methods of exploration and cannot prove whether the targeted deposit is viable or not. So drilling is the only method available to determine this. The process uses a diamond drill bit to drill down to the deposit. And unfortunately, because of its high cost, indirect methods are usually used before drilling to determine the best location to drill. And most of the time, there are drills in multiple sites to determine the size of the ore deposit itself. And lastly, we have remote sensing. Remote sensing uses aerial photographs to explore target sites without actually having to visit them. And these satellite images can create a three-dimensional image by locating the surface features. So basically the process is scanning the target area itself, and this creates the image for us, which can be two-dimensional or three-dimensional. And once this image is scanned, we can use colors to highlight particular features such as rock type, vegetation, or soil variety to determine where these ore deposits might be. And once these images are created, they are called false color images. Continuing on, this multispectral scanning depends on clear weather. So if there's cloud cover, it may not be possible to get an image. However, some forms of remote sensing are not affected by poor visibility. One of these remote sensing techniques is radar, and it is a form of microwave radiation that is able to penetrate cloud cover. Radar has been used to photograph the surface of Venus, and as we know, Venus is in a constant state of storms and cloud cover, so radar was used to penetrate this cloud cover to photograph the surface itself of Venus. There are other forms of radar, such as SLAR, which is side-looking airborne radar, and SAR, which is synthetic aperture radar. And these are sensitive to variations in the shape and terrain of the surface. So unfortunately, this picks up too many particles and can sometimes leave the terrain itself not looking the way it should. So this is where LiDAR comes in. LiDAR is light detection and ranging, and this uses laser lights to resolve subtle variations in surface topography. So this can be used to take away vegetation so we can get a better look at the surface to determine where these deposits may be. Well, I hope that you've learned a lot from this presentation and you found this very interesting. Thank you so much for watching.